Have you ever seen a flame so bright you could barely even look at it? Well, today we're diving into a classic science experiment that turns a simple little metal ribbon into an absolutely brilliant, dazzling flash of light. Let's solve the mystery of burning magnesium.
I mean, seriously, we are talking about a light so intense you really can't look right at it. And by the end of this quick explainer, you're going to understand all the science behind that flash, you'll know exactly what substances are involved, and you'll even be able to write out the reaction like a pro.
So we're going to treat this whole thing like a scientific mystery. And our main piece of evidence, our starting clue, is this pretty unassuming little strip of metal, a magnesium ribbon. So what secrets is it really hiding?
You know, every good investigation needs the right tools. Our kit for this one is pretty simple. Of course, there's the magnesium ribbon itself, then a piece of sandpaper, tongs to handle it safely, a heat source like a Bunsen burner, and a watch glass to collect our final evidence. That is literally all we need to crack this case.
Okay, before we get to the really dazzling part, let's talk about the single most important rule of any experiment: safety. Because a great scientist is always a safe scientist.
So here's the quick safety rundown. First, you hold the ribbon with tongs, not your fingers. Keep that flame a safe distance from you, and this one is critical. You never look directly at the burning magnesium. And of course, you should always do experiments like this with a teacher or a supervisor right there with you.
And the number one rule, the one that is absolutely non-negotiable, you gotta wear your safety goggles. Your eyes are way too important to risk.
All right, with our safety checks done and dusted, it is time to get this experiment started and see what clues this reaction is going to give us. Our little investigation has 4 main stages. First, we're going to prepare our evidence. Second, we'll handle it with care. Third, we apply some heat. And finally, the best part, we get to observe the reaction and collect the results. But hold on a second. Our procedure starts with a bit of a puzzle. The very first step is to clean the ribbon with sandpaper. Why would we need to do that? I mean, it already looks pretty clean and shiny, right?
Well, here's the solution to our first puzzle. Turns out that magnesium ribbon is hiding an invisible, protective layer of something called magnesium oxide. It forms naturally just from being exposed to the air. This layer kinda acts like a shield, and it stops the ribbon from burning easily. The sandpaper scrubs that invisible shield away, getting the pure magnesium underneath ready to react.
So the ribbon is clean, we're holding it with the tongs, we bring it over to the flame, and then it happens. Wow. It just ignites with this incredible, intense, dazzling white light. It's so bright, it's like having a tiny star right there in the lab, releasing a massive amount of energy. This very reaction, by the way, is the secret behind things like emergency flares, fireworks, and even those old-school camera flashbulbs.
Okay, wow. So after that spectacular show, the flame dies down. But what are we left with? You know, as scientists, the observation doesn't stop just because the flash is over. Now comes the fun part, analyzing the results.
I mean, just look at this transformation. We started with a solid, silvery, metallic ribbon, and what's left behind on our watch glass is a totally different substance, a delicate, crumbly white powder. A complete chemical change has happened right before our eyes.
So a new substance was formed, and a ton of energy was released. That is the textbook definition of a chemical reaction. So let's pull back the curtain and uncover the chemical secret of what just went down.
Believe it or not, the explanation is pretty straightforward. Our magnesium ribbon combined with the invisible oxygen gas that's all around us in the air. That heat from the burner was just a little push of energy needed to get the reaction started, and when they combined, they formed that new white powder, magnesium oxide.
Now, chemists have let's call it a more precise way of writing this recipe. This balanced chemical equation tells us that for every 2 atoms of magnesium, we need 1 molecule of oxygen, and that combines to produce exactly 2 units of magnesium oxide. It's a perfect chemical ratio. So what kind of reaction is this? Well, since 2 separate things, magnesium and oxygen, came together to form one single new thing, magnesium oxide, we call this a combination reaction. Kind of like, taking flour and eggs and combining them to make a single cake. And we can also look at this in another way. Because our magnesium gained oxygen atoms, we also call this an oxidation reaction. So it's both a combination reaction and an oxidation reaction. The name pretty much gives it away. Gaining oxygen is oxidation.
All right, let's wrap up our official case file. The product we created is called magnesium oxide. It's a white powder, and its creation released a huge amount of energy as both light and heat. The mystery is solved.
So, from just a simple metal strip, we created light, heat, and a brand new substance. It really makes you think, doesn't it? This one small reaction was so powerful. What other hidden chemical reactions are happening all around us, every single day, powering our world in ways we might not even see? Keep asking those questions. Thanks for joining me.